A phrase I found myself using a lot is mechanism. Now, by mechanism, I mean what are the stages something goes through? You can know what happens in terms of an end-to-end behaviour, but what does this person do? Do they look out the window and look out the window here and then look at the screen? What are the steps that are going on? Often quantitative data and statistics tell you about what happens. They say this occurs, this phenomenon occurs, how often does it occur, can you be sure that it's occurring rather than just random chance. So it tells you the phenomenon is there, but it doesn't explain why those phenomena actually happen. Typically you have to turn to qualitative data for that. That might be discussions with people, it might be videotape, but it's something that in order to unpack the stages that something goes through. So for instance, if somebody's using a mobile phone, then what buttons they press when, what screens happen, what do they have to look at on the screen, what perhaps goes through their heads as they're doing that. Also, we often use theoretical means to do that, and that would be particularly true for cognitive processes where you probably just don't have the behaviour to monitor exactly what's going on in somebody's head. But that's also true of the physical behaviour. So if somebody's pressing buttons, you can actually work out what's shown on the screen, how long the delays might have been whilst it's looking at the network or something like that. So why is mechanism so important? Particularly important for generalisation. From empirical data, the best you can often do is interpolate between things. So if I've measured what happens with a 10-point font, we'll come on to a font example in a moment, and what happens with a 12-point font, there's a good chance that the 11-point font's somewhere between the two. So you could, even then you could be a little, it doesn't always work, but you've got a good idea that, if one takes a certain amount of time to do, the other takes a different amount of time, the time from the one in the middle is going to be in the middle. That's interpolation. The thing it's incredibly difficult to do with from your data on its own, without anything else, is to extrapolate, to go beyond its limit. So you've run an experiment on font sizes, you've done 10-point font, you've done 12-point font, you've done 14-point font. What about 16, 18, 20, 8, 6, 4-point fonts, going outside the range? And what about something completely different? So you've done your experiment on font size on a mobile phone, for example. Does that apply if you're looking at a tablet? Does it apply if you go from an LCD display to one of those paper displays? So doing something completely different. Now, understanding why something happens doesn't mean you can magically just give perfect answers to all these things, but you're in a much better position if you understand why it was that one font size is better than another to actually go beyond this. Now, I've been using font size as an example, and the reason for that is I'm going to tell you about a paper from a few years ago. So this was at in a journal, and I won't tell you the exact journal. It's quite a long time back, so I hope it won't embarrass the authors if they notice I'm talking about it. It was about mobile font sizes, and in the early days of when people were using mobiles for data. So this was actually quite an important paper in terms of being early on in that process. They did a very well conducted experiment, chose their tasks well. They ran their experiment. From what was reported, it seemed they ran it well. And they got their statistically significant results. They got their p-values and they could do things. In their conclusions, they actually said what was the best font size. And this is problematic in a number of reasons. I mean, one was the fact that the technology might change. So mobile phones have changed considerably in the sort of the screen resolutions that you have available. They weren't taking that kind of thing into account when they gave this advice. However, more than that, they had a particular task, which was a menu selection task, and they quoted this overall best font size at the end. But the task they had involved looking on the screen to see whether the selection you're after. So they had a menu, the person was given things to look up in the menu. So first of all, you have to look at the screen. So obviously if you have a smaller font, it's harder to see. If it's a bigger font, it'll be quicker to see. So obviously bigger fonts can be better for quickly seeing if it's on the screen. If it's not on the screen and you have to click to get to the next page of the menu, it's a sort of paged menu, then clearly the bigger the font is, the less items are on the screen, the more pages you have to go through. So if you're paging, that's going to be worse with big fonts and better with small fonts. And then finally, when they get to the page, they think, aha, that's got the menu item I'm after. They have to select the menu. Now again, if it's a very small font, they're going to have to work very hard to get their finger just into the right place. You get the sort of fat finger problems. So, or possibly even make errors at that point because they click the wrong one. Whereas a big font's going to be easy to hit. So you can see there's 3 stages, and the first stage and the last stage are going to be better with big fonts, the middle stage better with small fonts. If the menus were very, very big, if there were big lists of things to go through in your application, then actually probably you're going to be better off with smaller fonts, and maybe doing something clever at the end to do the final selection. If you have very small menus, then probably going to be better off with bigger fonts. They could have actually given the data that would enable you to make that sort of decision by, and almost certainly actually they had the trace data. They'd run on their mobile phones, they were tracing, or I think most of the key clicks and presses that people were doing. So my guess is they could have split these up into these stages, produced separate analysis for each stage, and ended up with really useful data that could have been used for generalisation. As it was, not only could you not generalise well from their results, but if you just read the conclusions, you'd have had something that was deeply misleading.